So welcome everyone. This is our second webinar in the series, discovering about artificial intelligence. Today's all about AI and conventional programming. If you did the last session, the intro was really just a broad brush introduction into AI, but it sort of whet your appetite, I would imagine, in terms of what's coming up. And this one is no different. It'll be Nathan will be going through some programming. It'd be interesting to see what Carson's got up his sleeve in terms of some AI visualization. So I think it'll be another great session. Before we get started, I just want to do an acknowledgement of country. So ESA, that's the company that I work for. We acknowledge the Eastern Kulin Nation. They're the traditional custodians on the land where we've got our head offices, and we pay our respects to elders past, present and emerging. And I'm on the lands of the Bunurong people, but we recognise the traditional custodians of country across Australia. So wherever you're meeting from, we recognise the traditional custodians. So I'm going to hand it over to Nathan, and I'm really looking forward to seeing how you go today with all the great ideas that you should be jotting down as we go along. So Nathan.
Thanks, Martin. Great. Yeah, welcome everybody. Today is going to be a little bit different. Hopefully many of you attended the intro session last week this time. And this time around, this is deep dive number 1. And today's theme is to look at the sort of the differences and similarities between AI and then doing conventional programming. And in secondary years, of course, that's general purpose programming. So here's some of the things we're hoping you'll get out of today. You'll be able to talk to your students a bit about how machine learning differs from traditional code, especially in terms of the way it looks at data. And then the bulk of today, we're going to be doing a hands-on example of writing a conventional program and then adding AI decisions to it. And we'll get to that in the middle of the session today. I want to sort of say initially, though, that it may not get an opportunity to actually follow through hands-on yourself. You may be better off just observing. This video will be available to watch at your own pace once it's published soon after this event. So you will be able to access it and pause it and follow along with what's going on then. So yeah, we won't necessarily be slowing down in the session today when we're doing it, but please know that you can watch it back later if you really wanted to do that worked example yourself. And then at the end of today's session, we're going to be looking a bit at assessment and coding pedagogies, some of the interesting challenges that AI brings and that general purpose programming, of course, brings when you're teaching it. And Martin's also got some important information about privacy and some of the challenges around AI and student privacy. So let's get started. I wanted to start by just a quick look at the achievement standards from the Australian curriculum for digital technologies. I've highlighted from year 6 because it is a continuum. It goes all the way from primary into secondary. So at year 6, students are defining problems in terms of data and functional requirements. They have to incorporate decision making and repetition and UI design into their designs. So that's what we have at year 6. Now by year 8, so in year 7 and 8, we've got 2 bits that we've highlighted here that are relevant. Students are explaining how text, image, and audio data is represented. And so we're talking a bit about that, the way data goes into an AI system. But also, as I said in that worked example, we'll be looking at how students are going to be designing user experiences and the algorithms they make. And we've got these terms like branching, your if and then statements, iterations, your loops, and implementing code in a general purpose language. And at 9 and 10, it gets a little bit more formal. We start to talk about modular programs and data structures and all of those sorts of things. But once again, we are mainly focused on the general purpose coding today. All right. We brought this slide up in the intro session, just a reminder that the AI topics that we discuss in these deep dives ties in not just to that digital technologies curriculum in the middle there, but also to the 3 general capabilities in the Australian curriculum: ethical, ICT, and critical and creative thinking. And in particular, these are some of the foci or the specific concepts in the Digitech curriculum that we are going to connect with today The biggest one will be algorithms and coding, but we'll also be connecting a little bit with problem solving itself, the design thinking process, and with data representation as well. Okay. And of course, we'll be utilizing all three of the ways of thinking that are at the heart of the curriculum, particularly today, computational thinking and a little bit of design thinking as well. All right. So as we kick off, artificial intelligence and conventional programming, what are the differences and what are the opportunities here? I wanted to point once again to that explainer video. Martin will be sharing with you in the chat a link that will give you access to a kind of an overview table PDF that will have links to all the different things. So whenever we link things in this slideshow, you should be able to access the link to that through that document. And occasionally Martin will give you the direct link as well in the chat. But that explainer video is a great little intro to how AI works and how machine learning works. You might remember this if you attended the intro session. In traditional programming, when we look at our simple data system or digital system, we have an input. And in this case, it's a simple number, a temperature level, maybe in degrees Celsius. We have a process, in this case, a very simple decision. If the temperature is less than 19, we know it's jumper weather. And the output is we wear a jumper. Now, in AI or in machine learning, it's a little bit different. First, we have to train the AI. And in the case of training, we provide it with an image, say a shark, and lots of different images of sharks. And importantly, we label that image. We say to the AI, this is what a shark looks like as we're providing that learning to it. And the AI system then prepares a kind of a model, which is like the way the different neurons in your brain start to be set up in a certain way so that you can recognize things. And then by the end of it, we do the same for a dolphin, lots of photos of dolphins. And by the end of it, we're able to give it an image that's not labeled, and it can check its model. It can check all those neuron branches and decide whether or not it's seeing a shark. And in this case, we would hope after training properly, it will be able to recognize a shark with some degree of confidence. So again, the difference probably in the input data is that in traditional programming, it tends to favor discrete quantifiable data where we can clearly say if this, then that. Whereas with machine learning, it tends to favor data that's a little bit perhaps more fuzzy, a little bit less quantifiable, but data like sounds, images, sensory data, and often very large amounts of that data in order to train it and test it. Now, I believe we've got Carsten giving us another visualization of an AI and what makes it different from a conventional program. And in this case, I believe one of the keys is that AIs are able to draw on similarities, and the way that they make their connections is a bit different. So I'll hand over to Carsten to do that now.
Okay, thanks very much, Nathan. So here we have a scenario which is in the home automation realm, and perhaps some of you already have home automation solutions going at home. You come into the living room and you want the lights to go on, and then you say to your smart appliances, turn lights on or turn lights off, or turn the fan on and turn the fan off. And in this little demonstration, we just want to take a look behind the curtain of how these things might work. We start here with building a little AI model, and you see I have the AI here at the top. This is like the AI, it's like a newborn. It's not been trained yet. It doesn't know anything yet, has seen no data. So we have to give it data. We have to train it. And I have 4 buckets here. You see those 4 buckets on the left. It's lights on, lights off, fan on, and fan off. Now, we need to give our AI data. And in order to do that, I need your help. I need now from you some data, and I can't see the chat at the moment as I'm sharing the screen. So Nathan, could I get your help then? Whatever is typed into the chat, could you yell it out? And we start with an example, please. I need an example. What could we say to the AI if we want the lights on? Please type into the chat. And I will type it into the AI.
So what kind of a command would you yell out? So we got turn on the lights.
Okay, let me type this in. Turn on the lights. Very good. Now give me an example, please, for, sorry, before I do that, see how we're building up the AI model here. So the words turn on the lights, the individual inputs into our AI. Okay, so as I typed them in, they became inputs for the AI. That's happening in the background. Now, and I need an example for lights off, please.
Lights off. We've got turn lights off. Turn off the lights.
Lights off. Very good. Okay, now I need an example for turning on the fan.
There was a good one there for turn off also. Are you going to be adding more afterwards?
Yeah, I can do that anytime. Yeah, just shoot it out.
Make it dark.
Make it dark. Very good.
Okay.
Since we're on it, give me another one for lights off, please. And then we complete that thing.
Kill light.
Kill light. Okay.
As long as it's not like a Skynet AI.
Okay.
Right.
So can we have a fan on scenario then?
So we've got fans on.
Fans on. Okay, give me more.
Turn fan on.
Turn fan on. We can also say something indirect like it's too hot.
Oh yeah, we got a few coming in like that. So wow, it's hot. Cool me down. Yeah.
Okay, so for fan off.
Fan off could be, what could we have for fan off? Too cold.
Too cold. What else?
We got, I'm freezing. I'm cold now.
I am freezing. Very good.
We probably should put on a more standard one like stop fan. That's a good one, I think.
Stop fan. Okay, now I need two more for lights on to complete that picture.
What else could we have for lights on? It's dark.
It is too dark. It is dark. And last one.
I can't see. Make it bright.
Okay, make it bright. I go for make it bright. So
let there be light. I like that.
Let there be light. Okay, sorry, I do that now. Let there be light.
Really want that one.
Okay, right. Of course, we're done now. We've got enough data. We would, of course, if we were to develop an industrial product, we would collect hundreds and hundreds of scenario examples. Okay, but we have got now 12 here, 3, 6, 9, 12 in 4 different categories, so we can turn on the lights on, off, and the fan on and off. Now we've got data, but and you see that when I go through the examples that turn on the lights, that is categorized as lights on. So we have put it into the bucket, and when we train the AI, we are telling it that this means lights on. And for the next one, like turn lights off, we've labeled it lights off. Too cold, fan off. Okay, so you see this correlation between the input and the output. Now, what we are doing now, and I start this slowly, is that we start the learning process. I will talk more about that later in the next demonstration, but we're now showing these examples to the AI, and we're telling it what it means. And then the AI will say, that's what I'm supposed to see. I'm not seeing it. I'm not getting it right. I've made a mistake. And then it self-corrects. This is a process called back propagation. Now you see the colors changing here. And you see that actually more pronounced if I speed up the process. And here we go. Wouldn't it be wonderful if our students could learn that fast? But our AI is now getting a better and better and better grip of what input and output means. All right, so I can now go through this, and I see here too cold means fan off, and I am freezing means fan off and kill lights. Okay, so that's our learning data. But now I actually want to do something with the AI, so I'm typing something in. You could say, Nathan, what would you say to the AI now if you want, let's say, the lights on? What could we tell the AI? That is different from
something a bit different. Well, make it bright was one of the ones, although it might have some issues with that because I don't think we ever gave it the word bright.
Exactly. And that's actually already a good example because the AI is limited by its learning data. We haven't told it what bright means. So it would say make it is actually an indication of lights off for the AI. So we do something else. Make it light.
Yeah, make it light.
Make it light. Again, it's not trained well enough that it would actually pick that up because although it should actually, because we've got kill light in lights off. Okay.
So we've kind of confused it a little. All right, could we try too dark?
If we say too dark, okay. Too dark. It's not so well trained.
Can we try lights on?
Lights on. So here lights on is very weak, but it is actually certain that it's more lights on than it is actually lights off. You see the shading here, and it's definitely not fan on. So you see we've given it very little data here, and that still allows the AI to fill in the gaps. But because we've given it not actually enough information, it's doing a very poor job. So the solution here is to give the AI more examples than just 3 in each category.
Just before you turn, before you go off there, Carsten, this will be relevant for later, but you see all those green and red lines that have developed in Carsten's visualization there. Those are essentially, when later on when I'm talking about an AI model is basically a capture of all of those lines, all those kind of neurons, whether they're strong or weak. And that's what we take into our AI model so that we can test it later.
Yeah. And that's then, Nathan, when we store an AI model, we do not need the original data anymore. Okay, that kind of goes away. The AI then remembers is all its configuration in terms of how many neurons per layer, and these weight factors that we have here in the table. That goes to the AI model. Yeah.
Yeah. Cool. All right.
Okay.
I'll just share my screen again.
Back to you, Nathan.
All right. So hopefully everyone can see me again. Just give me the thumbs up. Yep. Okay. Now, just a couple of considerations. Where does AI kind of add, I suppose, in our teaching of Digitech, and how's the best time to combine them? We've done a little kind of split them into 2 here. You'll notice that on the left side, the conventional programming side, we've put the concepts of algorithms and implementation on the left side, and we haven't got those 2 things on the right side. And the reason for that is, while it is theoretically possible for students to code a actual neural net, like do the code that makes an AI work, it's very, very complicated. And in one of the future deep dives, I'll give you a screenshot of some of the code to make a really simple neural net. And it is probably way too complicated for students to be given as a task, at least in year 7 and 8, and probably 9 and 10, unless they're really wanting to extend themselves. So we can use general purpose to take advantage of AI models that we train, but we won't be actually coding a neural net itself in general purpose code. But what can AI do? Well, we can use it to talk about data representation. We can use it to talk about how text and images and audio and all those things become binary and then are fed into the AI system. We can use it to talk about data collection. It can be one of our things. Instead of just using a spreadsheet every time, we could try using an AI as part of our data interpretation and data collection stuff. And similarly, AI lets us talk about impact a lot. There's so many things around ethics, around how systems affect society that AI comes into as well. So let's get into a hands-on example. And here's what we're going to do pretty simply. We're going to write a program. We're going to use an online environment. We're going to write a JavaScript program. It's going to be a simple 1-question quiz. It's basically going to ask a question. I think the question is, is Mercury the closest planet to the sun? Something like that. The user will then answer by pressing Y or N on the keyboard. But we're going to upgrade it after that. We're going to upgrade it to have a different user interface so that the user will be able to put their thumb in front of their webcam, and they're going to do thumbs up or thumbs down like this. And instead of pressing Y or N, the program will recognize whether they've got their thumb up or their thumb down, and it'll accept that instead of pressing Y or N on the keyboard. So that's the example we're going to do today. And the way we're going to do that, 3 parts. We'll design and code the conventional program. We're going to use the P5 JavaScript environment. It's online. It ties in nicely with our AI stuff, and it also ties in with the webcam, at least on most browsers. So you should be able to use it on most browsers. Then we will prepare an AI model, and we're going to do that in a separate environment called Google Teachable Machine. It's a nice, simple, very straightforward environment that we'll just give you an intro to. And then we'll take that model that we've trained in the Google Teachable Machine. They will give us a nice URL for it. We'll bring that back into our conventional program, and we'll do that upgrade, where we upgrade to the interface with the thumbs up and thumbs down. So that's our plan. That's what we're intending to do. So let's start with our conventional program and how it begins. We want to do a quiz. Here's a bunch of bits of our flowchart. Of course, if you're teaching secondary, you might be moving the students on. In addition to flowcharts, you might do a bit of structured English or a bit of pseudocode as well. But let's have a look at it in terms of a flowchart. And we're going to start. We're going to ask the quiz question, and we're simply going to wait for the user to press a key. If they press Y, that means their answer is yes. If they press N, it means their answer is no. And then once we get an answer, either yes or no, we will display a result based on that answer. So that's a very simplistic diagram of our quite simple quiz program. And how are we going to do it? Well, we're going to code it in this P5 environment. That screenshot, don't worry too much about that. The two links that are on here and the link that Martin will soon be putting into the chat will give you that starting point for the program. And if you're going to be doing this and follow it, if you were going to be doing this on your own later, if you're watching the video and you wanted to have that starting point, you would follow that link there. So I'm going to now switch over to that starting point to show you what it would look like. And the reason I've given you the starting point link is because some code is already in place, code that we need to make the webcam work. But there's also a little bit of other code, because this is JavaScript, there's a little bit of other code going on in the HTML that's already in place as well, so that you and your students wouldn't need to actually put that in. But this is basically where we're going to start from. And at the moment, all this program does is start up the webcam and draw the webcam on the screen. You might be thinking, well, if it's only keyboard input at the beginning, do we really need the webcam? No, we don't, but of course we will be using the webcam later, so we may as well start it up now. So what I'm going to do is I'm going to switch my camera over. So if you are looking at me, you're probably going to be seeing me from the side now. And then I'm going to be pressing play here. And this should use my front webcam. There we go. So there's me. And that's all this program does, is just showing me on the webcam. Now, in order to make this program work, we're going to start adding some code to do the quiz. This is JavaScript, so I'm going to start by a bit of declaration here. I'm going to declare a variable called answer. And then down in our draw function, the draw function is the one that happens all the time, keeps repeating. We're going to ask the question. So, next up on the screen, is Earth the closest planet to the sun? And of course, the correct answer to this question is no, right? So, comma, we want it to appear in the middle of the screen, so we're going to go width divided by 2 to get it in the middle, and then 100 from the top, so it should be sort of near the top as well. So let's run that and see if that text appears. There it is. And my webcam will still be there in the background, but you can see it's now got the text, is Earth the closest planet to the sun, in front. Now, next thing we're going to do is we're going to actually respond to the person's input when they press Y or N. So we need a result string, and the result will be, at the beginning, it'll be waiting for you to respond. That's going to be the initial results string. And let's put that on the screen as well. So we'll display the result. We'll also put it in the middle horizontally, and we'll put it at the bottom of the screen. So that's height minus 100. Just going to give myself a bit of space so we can move that up. Okay, let's run that. So now we've added that result part as well. And at the moment, all it does is say, waiting for you to respond at the bottom. So that's working well. So now, like some other systems you may have used, this is an event trigger thing. So we have an event that triggers when the user presses a key. So we go function key typed. And this will be triggered whenever a key is typed on the keyboard. And it's a very simple little set of instructions here. If the key equals Y, so if the key that they pressed was Y, then their answer is yes. All right. And if the key that they put in is N, then the answer is no. Now, will that change the program? Let's see. If I press Y or N, will anything change? No, we've set the variable, but our code here hasn't changed anything that we see yet. So the last thing we need to do now is to actually check if they got the answer right. So we initially said our result is waiting for you to respond. So now we're going to check how they went with their answer. So if their answer is yes, our result's going to be incorrect. It's mercury. Now, otherwise, if their answer is no, the result is going to be correct. Now, those people who are used to Python, you're probably looking at all these curly brackets and semicolons and thinking, oh, JavaScript. I've sort of, it's my home language, I suppose. I did a lot of Java. So I'm not bothered by all these curly brackets and semicolons. But if you're a Python person, that's probably going to be looking a little bit frustrating for you. But it is so many ways, it's so similar. It's just the syntax is different here. So this should work. Let's press play. Here we go. Now I'm going to use the keyboard. If I press Y on the keyboard, incorrect, it's mercury. And it will actually let me try again. If I now press N, correct. If I press Y again, incorrect. So it lets me keep trying forever, really. It never goes on to another question. It just lets me keep pressing Y or N all the time and gives me that result underneath. All right, so that's basically our conventional program done. Now, if you wanted to see the finished version of that, there is the link there in the thing, and it's also in the resource doc, the PDF. But you can go straight to the finished program as well if you wanted to follow that link and see that. Now, I've just realized too, what I've just done is make a whole bunch of changes to the starting program. So I'm going to have to undo all of those later. I should have duplicated it. Anyway, let's keep going. Now, what we wanted to do next was to upgrade our interface so that we could use our thumbs to give Y or N. So to do this, we asked the question first, what can we do to represent Y or N clearly? And this is a discussion you could have with your students. If you're doing a user interface, something that's probably pretty broadly accepted is thumbs up and thumbs down. Sort of, I guess, goes all the way back to the Romans, doesn't it? But we could possibly use something else. What's something else that we could use that doesn't require showing a student's face? Well, one option could be something like sign language, Auslan, right? What about Auslan for Y and for N? We'll talk about this a little, but one of the issues with using sign language is it's a little bit more complicated and often requires movement of the hands as well. So it's not necessarily the easiest choice to do with an AI, although you can certainly try it and see how far you can get with it. Another option that I quite like would be like something like semaphore. So you have the student facing away from the camera, but you get to see their whole body as they move their arms and do the semaphore and do the letters that way. That could be a fun approach. The point is, though, we're going to need multiple photos and different angles and directions to make sure we're capturing the hand in as many ways as possible. As Carsten was showing before, we really want a range of data and lots of data to train this thing. Now, to do this, well, the system we're going to use is Google Teachable Machine. This is a website. There's, once again, a link to that in the resource doc. But basically, you collect your data, and then you train the model, and you can collect it straight from the webcam really, really fast. I am going to quickly show you what it looks like, but unfortunately, it's unable to adapt to my other webcams. So when I try to hit the webcam button to record my data, it tries to use the webcam that's already in use. So I won't actually take you through this process, but the first thing that you would do is you would set the names for your two options here, and they're called classes here, but what they are is your labels. So label number 1 is thumbs up. Label number 2 is thumbs down. And then you would go through the process of using the webcam to take a whole lot of photos of you, putting your thumb up in different directions and stuff, but making sure they're always thumbs up. Same thing with thumbs down. And then you would hit this train model button. And that might take a little while, depending on how many photos you've taken. Now, we're going to have a little bit of a side lesson again from Carsten as we get to this training stage, because he's done another little visualization that will show you what's actually going on. We don't get to see what happens when we hit that train model button, but Carsten's going to give you a little visualization of what's kind of going on underneath. So I'll hand over to him again now.
Okay, thank you, Nathan. So what we have here on the screen is another experiment in the My Computer Brain AI. It's not published. I'm going to publish it a little bit later, probably tomorrow. But it's a simpler version of the thumbs up, thumbs down experiment, and it's this thumbs upper. And what you see here are various pictures of thumbs up and pictures of thumbs down. And you notice that I've done more than one in order to give the AI a bit of variety, because otherwise it would get used to the thumbs up, thumbs down just being in specific places, but we are more interested in the general shape. And again, like before, with the home automation scenario and aligned with what Nathan has shown you, we've got these two classes or these two buckets, thumbs up and down. And again, we've done the same thing. We are telling the AI that this image now is a thumbs up and that this image here represents a thumbs down. So what Nathan has done before, but which couldn't show because of the camera, is that there's now a learning process kicking off, which I'm going to start here. I'm doing this very slowly. And the same thing would happen in Teachable Machine, where the images of the thumbs up are being shown to the AI with the information, hey, this is thumbs up. And then after that's done, then the images of the thumbs down are being shown to the AI. And this little box here represents on the right, this is now a thumbs down. Ignore that this here is black. The AI is not trained yet. It is still learning, so it doesn't know to distinguish thumbs up and thumbs down yet. And again, you see the colors of these lines changing, so our model is gradually being built. And I can speed this up again. Okay, so you can see how very quickly we are showing all the images of thumbs up and thumbs down to our little AI. And our AI says, oh, okay, that's what it is. And oh, unfortunately, I'm making a mistake. I need to correct. So this back propagation process kicks in where the error is being recognized and then distributed across each participating perceptron. So these little lines are being updated. And you see our dial, our knowledge dial, is slowly but gradually moving to the right. A little maybe interesting fact is we never know how many cycles it will take. The reason for that is we always start with random numbers, very small random numbers. When we initialize the AI, they're actually necessary for the AI to learn. I've tried it out. If I initialize these weight factors with the same number, then the AI is completely unable to learn. It will just get stuck. So AI needs small, subtle differences in order to learn. And a little bit further to the right now, and our AI is still looking at all these images. So we've now done about 130 cycles. 130 cycles means that we have 130 times shown the AI all the pictures. Okay, can you imagine how long learning takes? And that's probably the reason why our students need to go to school for 12 years and they're not done within 1 year. So learning is a process. And you see sometimes it's going backwards. Okay, so the AI has moved itself into a little bit of a local minimum from which it needs to get out. It's a little bit like when you are traveling through, let's say, the Alps, and you've come to a valley, which is not the deepest valley in the Alps, but in order to get to a deeper valley, you need to climb over a mountain, okay, which is the equivalent of the AI taking a step back. So you're climbing up the mountain again, looking around saying, there's a deeper valley over there. And then you're going down the hill.
There's so many good metaphors there for real learning as well, isn't there, for the way humans learn?
Yeah, and you're doing it blindfolded. Yeah. That's what the AI basically does. But just look at the data here. So our AI has now successfully learned what a thumbs up and thumbs down means. It's relatively certain it's getting that right. And again, if I now bring a picture in there that the AI does not know, for example, I've got a picture of a thumbs down, which looks like this. Let's do this. It's still pretty certain that this is thumbs down. That's quite impressive, considering that we've never shown it that particular picture. And again, that goes back to the point that we made earlier and at the last webinar, is that the AI is really good at working with information that deviates from the ideal case, from the case that we have taught the AI. It's able to fill in the gaps and still come back with quite reasonable suggestions. So that concludes my demonstration here to give you a bit of an insight into what would be happening inside Teachable Machine as it learns.
Brilliant. Thanks so much, Carsten. Yeah. All right. Just bring my stuff back on here. All right. So to continue on, so that's kind of what was going on under the hood when we hit that train model button. Once it is trained, then Teachable Machine gives you this option to export your model. And what actually happens, well, first you can have a chance to test it. And you can see I tested it with thumbs up, I tested it with thumbs down. You notice when I tested it in front of my stripy shirt there, it wasn't so good. It's not quite as confident as it was when it was just the plain blue background. And then I even tried doing this. I tried doing just my hand not in either position, and it really struggled with that. I would have thought it would be closer to a thumbs up than a thumbs down, but it actually struggled with when I wasn't giving it a clear thumbs up or thumbs down. Anyway, we press that export model button, and what happens next? It brings up this other little dialog here, and it allows us to upload our model, and then it will host that model. And as we were talking about, the model is kind of like a map of all those little lines, all those little weightings, and that allows it to recognize the thumbs from that point on. So we upload our model, and once we've done that, it provides us with a unique URL that can be used in online environments for programming. In this case, we're going to use it in the P5 environment. So that little URL there is what we need when we go back to our conventional program if we want to integrate this AI into it. So this is the final step. We're now going to take this into our program and bring in that URL. Now, I have set up a new starting point program from here, which I'm about to go to. And that's where we're going to bring in, the reason I made a new one is just so that you can have access to that URL without me having to type it in all the way from scratch. It's just going to be pasted in there already. So let's head straight into that new starting point now. And here it is. And as you can see, I've got that nice URL for my pre-made model. It's like one of those cooking shows. Here's what I made earlier. And that's my pre-made model that I made earlier there. So getting started then, let's finish off this program now so that it doesn't just use the keyboard, but it can also see my webcam and see me holding up my thumbs. Now to do this, we need to introduce a new object. So I'm going to declare it here, and it is a classifier. And the libraries or the stuff that it needs is all sort of already built in because of the way we set up this program. We are going to make a function called preload. And in this function, we're going to set up this classifier object. So the code for this is fairly simple. Classifier, and it uses this thing called ML5, machine learning 5.image classifier. And then we simply give it that URL. So I'm going to take that and I'm going to paste it in there. So that's the code for the preload. We've now set up our classifier. So that's going to be the thing that we use to tell whether we've got our thumb up or down. And then we add a line down here in the setup. And this is where we begin classifying. So classifier.classify from what? From the video, from what's coming in from the webcam. And what do we want to do? If it sees something, we want it to actually trigger a function. So the trigger function will be called got_results. And just like the function that we made here for key typed, our got_results function is going to be a similar sort of thing, except instead of looking at the keyboard, it's going to look at the results from the AI, from the webcam. The good thing about this is we don't have to change anything here, because we're just going to be giving it different answers depending on looking at our thumbs. So this whole draw function just stays exactly the same. We don't touch it. Our key typed stays there. We can still use the keyboard if we want, but now we're going to do our function got_results that will look at the webcam. So function got_results. Now there's two parameters for it, error and results. And here's what it's going to do. Results parameter is actually a list, an array, and we're only ever interested in the first item in that array, result 0. And what we're saying is if the confidence is greater than 0.5, in other words, if we're at least 50% or more than 50% confident that we've got a good result, that we know it's thumbs up or thumbs down, then let's continue. Now, if that result dot label is up, in other words, if it saw, when it looked at the webcam footage, it saw my hand doing a thumbs up, then we set the answer to yes. So up here, if the key was Y, we set the answer to yes. Here, if it saw the thumbs up, we set the answer to yes. Very similar sort of way of doing the code. It's just a different trigger. Now we can do a similar thing with thumbs down. So if results 0.label equals thumbs down, then the answer is no. Right? That's the answer I'm supplying with my thumb. Now, at the end of all this, we do have to tell the classifier to go again. So just the same line as we did right at the start, tell it to go again so that it will keep checking, so that it doesn't just check once. And there is one other bit we can put in to check for errors, to use that error thing, but I think we'll be all right to run it without that. So let's give this a shot and see if it works. Now I'm going to get out of the way of my webcam. There's me. All right. So let's see if this works when I hold my thumb up. So I've got my thumb up. It's saying incorrect. Mercury is the closest one to the sun. Now, if I put my thumb down, it's correct. Thumb up, incorrect. Thumb down, correct. Notice it makes it's not always quite right, you know, but it's generally there. If I hold my thumb down, if I hold my thumb up, it's pretty good. There you go, correct, incorrect. Now, obviously, if we train the model a little better, we could improve that a bit. Just before I turn this webcam off here, this is pretty much finished now. Martin's going to talk a little bit later about having your students' faces on a webcam and the issues around that. So obviously, I wouldn't be necessarily having students' faces like this, but obviously their hands doing a thumbs up and thumbs down is okay. All right, we'll switch back to our slides. So I hope that was useful for you to see. There's Carson's thing again. I hope that was useful to see that finished program. I realized that might be a little too fast to go through for people if you're watching this live, but if you're interested in watching it back later to take it a bit slower and work through it, you will have access to those links in the slideshow and also in that resource doc. So you'll be able to access the starting points and the finished programs as you go through. Right. Now, we do have a couple of relevant lesson ideas as well that are pre-made, lessons that are already up on the Digitech Hub. One of them is a rock, paper, scissors challenge. It's instead of thumbs up, thumbs down, we train it to do rock, paper, scissors. The other one is a different type of program that uses pencil code environment, and this one is for general purpose programming. Now, I wanted to just quickly touch on a couple of things here. One is about Python. One of the reasons very few of these examples are being done in Python is that it can be difficult to find an online environment for Python that lets you access things like your microphone and your webcam in order to use this kind of input for AI. So that's probably why you won't see necessarily a lot of example lessons of this kind done in Python. There are ways to do it. It's just difficult to access hardware like microphones and webcams. The other thing to note here is this lesson on the right, the one with the pencil code environment. It was originally written to allow the student to speak into the program, use speech recognition, but later on Martin's going to be showing you how you can do it without using the student's own voice and have a computer talk instead. So our last part of today's session, we're going to talk a little bit about pedagogy, property and privacy. So some of the challenges that we get when we're teaching coding and when we're teaching coding, particularly with AI. So first of all, the concept of remixing. And this is a challenge you might find no matter whether you're doing AI or not, but if you're doing any kind of general purpose coding, and even with visual coding, that students, and in the real world, programmers will often remix code that already exists. They'll find usually a short bit of code that they want to use that does a certain job. They want to bring it into their own program and remix and use it. It's very normal in real world programming, and there's a certain line between doing that and just outright copying someone else's intellectual property. So this is an evidence-based approach, teaching your students in a way where they're not just starting with a completely empty slate, and also teaching your students in a way where they're not just being given a complete program to copy out. And there's a kind of an in-between that we can reach here. So two of the models that are examples of this is one's called PRIM, predict, run, investigate, modify, and make. And there's another that adapts that use, modify, create model. When a learner is using, they're basically taking an existing program. When they're modifying, they're like tinkering with the program, making some little changes to an existing program maybe at the teacher's instruction or things they want to try themselves. And then the create part, the green one, is where they get to do something from scratch on their own. So what we're trying to do here is to say it's not just about students copying out a big existing program and that's it, because if that happens, they may not be learning how coding actually works. But it's also not about every time a student starting from an empty screen and doing their programs there. There needs to be a mix of adapting and tinkering with existing code as well. If we were to apply this principle, yes,
Nathan,
sorry.
Just to chime in here, that's how, for example, I got into electronics. I took the transistor radio of my parents apart, much, not to their joy, but I learned a lot along the way. Was I able to bring it back together? Not entirely sure that went, but tinkering with existing stuff, and I really like the PRIM model, because starting from scratch is really hard when you're new to something. But looking at how something works, I mean, we all then reverse engineer basically, and there's so much learning in there. I find it personally very valuable.
Yeah, in terms of this tinkering, I really do believe in it myself. And what are some of the things we could possibly do, for example, in the project I just did, the worked example? Well, we could ask students, well, why don't you try adding a third label, a third gesture to the whole thing? So maybe a not sure answer. So thumbs up, thumbs down, and then something else, maybe, something like that, a third possibility. Another option is multiple choice quiz. Instead of yes and no, they have to answer A, B, C, and D. Maybe you have to edit the program so that it moves on from the first question and presents them with a second question, then a third question, and then gives a score. Or it could be a timed game. They have to choose the gesture quickly before the computer time runs out. These are all ways that you could tinker and apply changes to the program. One other thing to discuss as well is the issue of intellectual property. And intellectual property doesn't just apply to images and videos that students use and teachers use, but it does also apply to code. And there are, as I said, there is this line, and we don't always talk about where that line is between going on a forum and finding a bit of code that does what we need versus, copying an entire program and then putting our name on it. And I don't have an easy answer for you, but it's worth something discussing with your students and talking about. And then privacy, I might leave this section to Martin to talk about, but there are obviously issues around students photographing their own face, recording their voice, when doing AI activities. I already talked about a couple of alternatives, so students could maybe use semaphore and poses. They could hold up things. I noticed someone in the chat earlier suggested holding up images or smiley faces or sad faces, holding up toys, fruit and vegetables, recognizing those, and all those sorts of things as well. So Martin, I'll let you take over the next part.
All right, thanks Nathan, and well done on your instructing us about how to do that coding. That was an excellent process. So I'm looking forward to if people can do that themselves. But I think what I'm really pleased about is to be able to say to you that we do have from the eSafety Commissioner this document. It's an assessment tool, a risk assessment tool that's really going to help us working out when we're using this new technologies, how do we make sure that students are safe? We've talked about a bit about privacy and whether we don't want students' faces on the camera. We do want to teach them with machine. What are the issues and what do we need to look forward to? So this tool allows us to sort of provides a little bit of a checklist. And really, if you think about it, like COVID has done something good for us because it sort of moved the departments into a stage where, if we're doing online learning and home learning and we need some sort of platform that we can ensure that all our students are safe, it's forced us to look at, what is online learning, what are some of the risks, what do we need to be aware of, and as people use the technology, we worked out, sometimes that people could, from nowhere that we knew, could jump into our meeting, for example. So, all this new technology needed to, be worked through, and some of those issues worked through. And it's a lot like the tools we're using. We're probably pushing the envelope in terms of some of the things we're trying to do. So Nathan, if you can look at that next slide, this is the actual document itself. It sort of looks at some of these key elements. So the first one, will students' personal information be displayed publicly? Photograph, date of birth, gender, name of school. Obviously, we don't want that to happen. So, de-identifying, what are some of the risks, ways to mitigate the risks? De-identify student information. We're looking at where, if there's a communication sort of opportunity, for example, you might have a website which you're using, which students are creating content, and students can share their content and people can see their content and give feedback. Well, that sounds all good in theory, but then that opens the student up for bullying or for irresponsible messaging. So you try and then think, okay, well it was a great opportunity, but there's a lot of issues, so we don't really want to use something that has that facility. So again, you'll have that document I'll put in the chat once I finish speaking, but basically you've got a little bit of a step through. So Nathan, I think on the other slide here is privacy to go through. There's a lot of ideas here we can sort of go through. Are the staff comfortable in using the content, the particular approach that we've been using? Does it have a way to access or change the privacy settings? Is there information about privacy that's important? One of the things we'd advocate is, looking at the privacy information that's presented, and what if information, say, such as the emails requested from the user, what did they actually do with that? So we want to make sure that they don't pass any of that information on to a third party. So they're the sorts of things you're looking at. But I thought, Nathan, just to build on what you've been saying, and you had that home automation program, and so here we are. Here's Nathan's in the program. Basically, the students create a program which requests their speech. So you can see here, this is the actual program, and if I run it, turn light on. There it is, it works. So what we don't want the students to be able to put in a voice in, so I don't mind mine. I'm an adult, so I can make the decision that I'm fine with it. But we don't want our students to be able to do that. So what we can do is run another program which basically turns the text into someone else's speech. So you can see here, I've got this running. And
Turn on the light.
so now I could just refresh that program. Try it this time.
Turn on the light.
So you can see there, after a lot of mucking around, sorry about that, the program sort of works. So you can have your screen back.
Thank you.
But it's just an opportunity there to sort of run the program without being having the risk of students' voices being captured. And I know, Carsten, when you are mentioning about how speech is actually captured, in these programs, we don't want the student's voice to be captured. But can you just give us a bit of an indication what the issue is there, so people know?
So increasingly, the banks are using voice prints for account authentication. Okay, so now not all of our students might have a bank account, depending on how old they are. But again, this is something very personal, like your date of birth or the name of your primary school, and this kind of information, when it's out in the wild and it can be stored for a long time, might eventually compromise your security and lead to identity theft. So that's why it's probably good advice to stay on the safe side with these very personal things of information.
Cool. Thank you. Just as we wrap up, we've got just a couple of minutes left. We had these assessment slides in our intro session as well, but I just wanted to briefly point out, we do have an example of a, hang on a minute, there we go. We do have an example of a suitable rubric or a possible rubric you might want to use for general purpose programming. And that link is in the overview table that's in that PDF as well, but I think Martin might paste it in as well for you. That's just an example of a rubric that you might use for general purpose programming to assess the different aspects of it and the way students are doing it. Yeah, there's a lot of ways you can assess the AI and, assessing how well students understand what's going on when they're training and testing it, and discussing the data they're using for training their model and how well it worked out when they tested it, and all those sorts of things. So these are all things that you can do as assessments in this area. And just as we're wrapping up here, oh yes, you've got screenshots. Sorry, I didn't realize. So yeah, so you got, for example, when they're doing their user interface, a great example is the user is presented with clear, complete instructions of appropriate, helpful responses, things like that. If it's a graphical interface, you might have a different set of rubrics there. How well they design their algorithms, how well they develop their code and their programming skills, and these would obviously depend on the year levels and so on. So yeah, I think we've reached the end of today's session there. So just a reminder about the lesson plans that are up on the hub. There's lesson plans for 5, 6, for 7, 8, for 9, 10. The website does allow you to filter according to concepts and according to the year levels that you're focused on. So do feel free to check those out. And yeah, a couple of those are ones that I linked in today's session as well. We're hitting the 5:30 mark, and it's a census night. So yeah, you can give some more data to the government. If you have any other questions or things that you would like to share or ask in the chat, please feel free to do so, and we'll keep an eye on that now. But otherwise, thank you so much for attending today and for taking part. And yeah, feel free to contact us via email as well if there's things you'd like to follow up with.